Hello everyone. So we are going to be talking about MPI messages in this presentation. Hi, I'm Preslin Peter from Christ University, and we would get into the agenda of the presentation before we start off. So the first we have the introduction to MPI messages, overview of MPI send and receive calls. Then we'd have an analogy where we'll discuss about MPI send and receive calls, comparing it to some real life example. And fourth, we have an algorithm for send and receive. Then we will discuss an algorithm of ping pong program. And last, we would have ring program. And after all this, we would conclude with elementary MPI data types. Now, we would go into the introduction. For the introduction, before we can understand what message passing interface is, it's very important for us to understand what MPI processes are. MPI processes are heavy-weighted, single-threaded processes. They have separate address spaces. One process cannot directly access variables in another process address space. So from this process, we have come into the need for message passing. So inter-process communication, which is required, is fulfilled by message passing. So what is MPI send and receive calls? So MPI send and receive calls, the process A decides a message needs to be sent to process B, and process A then packs up all of its necessary data into a buffer for process B. So when we say a buffer is generally can be compared to envelopes in our day-to-day life. So just like all the required letters and receipts are all bundled into one envelope when we send it to one sender, similarly, these buffers contain all these packed data, and they're all made into one buffer, and that is being sent to the required recipient. So this procedure gives us a detailed workflow on the MPI send and receive calls. We would now have a video presentation on explaining what MPI send and receive calls is so that we could understand it more easy and fast. So as we had seen in the analogy, this is a small summary which we can gain from this flowchart. So the first step, as we can see, is the first process. It makes the decision. So the first process is the sender, and the decision to send the message is made as the first step. After which, all the messages and data that need to be sent are packed into buffers. This buffer is then transferred to the recipient via a communication device. And this communication device is a network in a parallel programming scenario. After which, this whole process is complete only when the recipient gives the acknowledgement to process A. And after process A receives the acknowledgement, then he is free to do the next work. Until then, they wait for the acknowledgement. So after understanding what MPI messages and what their workflows are, and even we've gone through an analogy, I think now it's time that we understand an algorithm that is written to message sending and receiving calls. So send and receive. So we have two functions, as you can see, MPI send and MPI receive. So these are called as the MPI send and receive calls. And here we have the data, which is of type void, and we have another variable with count. And we have another data type of MPI data type. And we have destination. So this variable would note down the location where our message needs to be sent. And now if you can see, we have the MPI common communication network. So which you can see that it is present in both the calls. And we have the similar, only difference being here we mention the source. And we have the MPI status. So this status basically is if our receive call is willing to accept or acknowledge the message that has been sent by the send MPI send call. So now we have the send and receive algorithm. If you notice, we have two functions, which is the MPI send and the MPI receive. The MPI send involves the data types void data, int count, MPI data type, int destination, and int tag. And last, we have an MPI common communicator. Similarly, we have also the same things in MPI receive. And as understood, the sender function has the destination variable and the receiver function has the source variable. So the process here is the MPI sends the messages and we have the communicator here. And here also we have the common communicator which sends the acknowledgement back to the sender. And every time the status is updated based on the receiver's choice. So with this basic understanding, we can see this implementation in two more programs. First, we will go through the ping pong program. So when you see in the ping pong program, here this particular program will only work for two processes. We need to have one for the sender and the receiver. We start off with the ping pong count, which starts at 0, and we have its limit as 10. So this value can be updated as per the user's choice. So when we go through the complete program, this program can be simply explained by saying that each function, we have the sender and the receiver, but both these functions will interchange their roles uh, uh, for the processors. Like process A will be the sender and process B will be the receiver. And in the next iteration, process B will become the sender and process A will become the recipient. So this transfer of rules happens iteratively. And the next thing we can see is that the ping pong count keeps incrementing as and when the iteration count increases. And lastly, what we notice is that this particular iteration needs to stop, and that stops when it reaches the ping pong limit. So for our code, it is 10. So now we can see what the output of this program will look like. So now if you can see, for the first step, 0 has been sent and the incremented ping pong count is 1. Now it has become 2, and that's how it keeps increasing till 10. And what we notice also is that this happens till we get the process value as 0. So this is how the ping pong program works using the send and receive implementation. Now we have another program so that we can understand this even better. Now that we have seen about ping pong program where we are strictly allowed to use only 2 processes, now we come to ring program. And here we are given the freedom to use multiple processes, more than 2 processes. And how this process works, this process works. Firstly, the sender is starting from the first process, process 0. And process 0 sends its information or messages to each other process. So in our program, we are considering a total of 5 processes. Process 0, 1, 2, 3, and 4. So so what happens is till the response is received from the last process back to the first process, this particular program or algorithm is in function. So to tell in detail, the first process, that is process 0, sends its information to process 1. Then it sends it to process 2. And then it sends to process 3 and then to process 4. And when it receives the information finally from process 4, that's when the program comes to an end. And that's a successful completion. So let's see the output of this program to understand the logic better. So as we can see, we have run the program and the output we have received is process 1 has received the token 1 from -1 from process 0. So process 0 has initiated it. It has sent the information to process 1 and process whatever process 0 has sent, process 1 has received. So we get this message. Again, for process 2 also, we are getting the same. So process 1 is sending to process 2. And from process 2 is next sending to process 3. So as you can see, this is a ring fashion. So process 3 now is sending to 4. And now 4 is sending it to 0. So we saw that it started off with 0, which is the sender. And now the sender is getting the acknowledgement back. So here we have seen two types of programs based on the send and receive format. The first one was the ping program, where only two processes can be in place. And now we have seen a ring program where more than two processes, but they still work in the same functionality as the send and receive protocol. And now we have the elementary MPI data types. MPI data types, here we are seeing the MPI data types and their equivalent in C. So C program, we are all aware. So it would be easy for us to correlate how the data types that are defined in MPI are and what are their functions. So we have MPI short, which is similar to short int, and we have MPI int, which is also equal to short int. And even more precisely, the int data type. And we have MPI long and we have MPI long also. Then we have unsigned character, unsigned short. Then we have unsigned int, unsigned long int. And we have a float variable, we have a double, we have a long double, and we have a byte, which is equivalent to a character data type of C program. So that brings us to the end of MPI data types and their messages. So thank you for listening. Have a great day.